it's fairly safe to say you all know what a password is. It's a way of proving your identity to a computer system in order to get access to parts of the system that not everybody else has access to. Passwords these days are having to be increasingly complex, so you're having to use lowercase and uppercase characters, numbers and symbols, and a combination of all of these, along with having a minimum number of characters. Now the reason for this is it stops people as easily being able to use something called a brute force attack. So as a rough rule of thumb, if you're using a brute force attack, the number of attempts that it's going to take you to guess that password, which is basically you trying every possible combination, is going to be, so attempts is going to be equal to the number of characters to the power of the password length. So if you had the password computer, which has 8 lowercase characters, then what you will be doing is it's going to be 26 possible combinations, because there's 26 lowercase numbers in the alphabet, and that's going to be to the power of 8, which equals 208.827.064.576, just off the top of my head. If on the other hand you had the password computer 1 with a couple of uppercase characters, then what you've got is there are 26 possible lowercase characters, there are 26 possible uppercase characters, and there are 10 possible numbers that you could have, including 0. Therefore, you've got 62 to the power of 9 this time, because the password is now 9 characters long, which again, off the top of my head, is going to equal 13537086546263552. Quite a lot more than if we just had lowercase characters. Encryption is a way of scrambling up a message so that it can be sent from one device to another, and if it's intercepted en route, then it's not going to make a lot of sense to the person that gets hold of that message unless they have the key to decrypt it. The picture in the top left hand corner of the screen is a picture of the Enigma machine, which was used by the Nazis during World War II in order to try and send messages to each other, so that if the Allies were to get hold of them, they wouldn't know any of their plans. We of course all know that this wasn't the case, and Alan Turing and a small group of people at Bletchley Park managed to crack the code and were able to intercept a lot of German messages during World War II, which really helped the Allies' effort in winning the war. Now, one simple method of encryption that you need to be able to carry out is using the exclusive OR. Now, you've already looked at this, but just as a reminder, if we have two inputs, we have A and B. If input A and B are both off, then the output is also off. If we have one of them on, then the output is positive. So if we have the other one on, again the output is positive. However, with an exclusive OR, if both inputs are on, then the output switches to off. So the way this works is if you wanted to send the binary number 0111, you would have to encrypt it with the exclusive OR key, so we could encrypt it with 1010. And the way that then works is you use the exclusive OR truth table to figure out what the encrypted message is going to be. So 1 and 0 is going to be 1, 1 and 1 is going to be 0, 1 and 0 is going to be 1. So your encrypted message, which originally was 0111, ends up being 1101. Then what can happen is the person that receives the message uses the same key, which is this one here, to put the message back to its original form. So we've got a 1 and a 1, which you know is 0. We have a 0 and a 1, which is 1, a 1 and a 0, which is 1, and a 0 and a 1, which is 1. So you can see that the message can then be decrypted. So this is just a very simple method of encryption. The exam board mentions two others that you need to be aware of but not necessarily be able to do. One of them is SHA256, and the final one is called Blowfish. If you want to have a look at those on the internet just to figure out how they work, I would highly recommend that.